Hello everybody, this is a tutorial on how to use the 3D Makerpro Mole camera. This is for scanning 3D objects and importing them into your computer for use in a CAD software program. And so we'll be using a Lego brick as a demonstration. And so I'm going to go ahead, put that on the build plate, and show what the camera looks like. So it's just a camera on a tripod that might come with your specific model. And so go ahead and make sure that this is aligned onto the object, like so. So I have it pointing in the middle there. And so I'll place in the live footage along with what's being shown on the computer here. So if I move over to the software, I'm going to go ahead and switch to table scan, keep it on a brightness of 4 because I have ample lighting, and keep it on a sensitivity of 5. The 400 frames ensure I get one full revolution around the object, and so I'll leave it on geometry and deselect color scanning. So to initialize, you take away the Lego brick, make sure you don't get a scan of the build plate. And so I'll let it go for several seconds. Okay, so then put the Lego brick back on the build plate. And what I'll do is I have a power bank hooked up to the disk. And once I toggle the button and hit scan, it'll show whatever's in the green rectangle here to collect a bunch of data points. Now while it's spinning, notice here on the left it says excellent. This is the distance Goldilocks zone, so to speak, that shows it's not too far away from the camera and not too close to the camera. And after we scan one time, we have the choice to process the scan into a file, or you have the option to do another scan. And so now that it's done scanning, you could see that the scan in yellow is what will be captured, and what's in red is ready for deletion. The build plate in red was initialized as being not part of the scan from earlier, so all I'll do is hit the delete key and I'll delete the build plate. And so if we zoom in closer, you can see a collection of data points that bounced off the Lego brick and back into the camera's sensors. Instead of hitting process, I'm going to go back to table scan and do another scan. And so from here you have the option to make adjustments to the camera. You can even reorient the object to capture other detail if you want, but I'm going to go ahead and leave it on that. And so once again, take the object away and initialize it. And once you think it's done initializing, you go put your object back on and do another scan. And so shortly here, after it completes a second scan, I'll show how to align two scans together. You can do it either automatically or a manual way. The manual way allows for flexibility in how you align the two objects together if the auto align doesn't work. Okay, so it's going to rebuild yet again, and you'll see table scan number 2 appear on the right. Okay, and once again, I hit delete. And so now I have 2 scans. You can toggle the visibility here to make them appear. Notice as I do that in the align items section, they also appear there. So now I have the option to align. And notice that it didn't work. So it says here, if the results are not satisfactory, try manual alignment. So this feature of the program is a hit or miss. Sometimes you'll get them to align, sometimes you won't. So you can hit return, and instead of auto aligning, we're going to do a manual align. And so notice that each scan appear in the windows here. So it says rotate the models in the top 2 viewers until they're roughly in the same spot. So all that means is you get them roughly in the same spot, which that looks pretty good. And then you have 3 points in the plane here of notice that we are off by quite a bit here. So what I'll do is just start in this window and put them roughly in the same spot. I'll take that, put it there, select point 2, maybe I put it on top of one of the pegs there. And selecting point 3, I could do so by placing in the back corner. And so now when you go to align, it says finished. It doesn't give quite the result I wanted, so I'm going to return and keep playing around until the objects are roughly in the same orientation. So I'll go ahead once again, try and place them in the same positions. Maybe you try over here, 3 unique spots in the first locations. Try to align once more. And notice this time it looks a little better. You can see a mixture that closely resembles your scan. Now remember, you're never going to get a perfect model or a representation of your object. You can get very close to it. At least with this camera, I've had okay success. I've only had the camera for about 2 weeks, so with a little more experience, could definitely refine your results further and further. From here, since we have 2 aligned groupings of scans, I'm going to go ahead and process them. And so over here, I leave these toggled. I'll go ahead and repair any gaps, remove floating data points, like right up here. Here's one. And then there's a few more on the model that are present. So go ahead and process. I'll put brick. And then it asks, what do you want to do with the group? Do you want to make it refine it low, moderate, or high? I'll leave it on moderate. And it's going to go ahead and step through an algorithm to form your final scan in what's called a fusion. So just to recap, you have you can do multiple scans of an object, align them together into a group, and from there you can process the group into a raw 3D file. To get this out of the program, you can export the object and choose to reorient it if you want, but I'm not going to do that. You can make the object into an OBJ or the commonly used STL and save it, and then you're ready to open that in the CAD program of your choice. Thanks for watching.